Now we want to derive Torricelli's equation from Bernoulli's equation. And Torricelli's equation is a very simple little equation that just tells you the speed of a fluid flowing out of a hole in a reservoir. And the equation is just V is equal to the square root of 2GH. And this is the V we're referring to right here, which depends on the height of the fluid in the reservoir. So how do you get that from the really complicated looking Bernoulli's equation? So we'll start with Bernoulli's equation. As you know, P1 plus 1/2 rho V1 squared plus rho GH1 equals P2 plus 1/2 rho V2 squared plus rho GH2. The first thing we can do is label the two parts on here. So I'll say where the fluid is flowing out, we'll call that region 1, and the top of the liquid in this tank, we're just going to say that whole area is region 2. Well, since both of these areas are exposed to atmosphere, you have the water coming out into atmosphere and you have the top of the tank at atmospheric pressure, we can say that the P1 is equal to the P2, because that is just atmosphere. Which means I can subtract that from the equation and those terms are just gone. So now we have just 4 terms left in the equation, and you can note that all 4 terms have the density in them, so I can just cancel all 4 of the rows, which leaves you with the equation 1/2 V1 squared plus GH1 equals 1/2 V2 squared plus GH2. Since region 1 is down at the bottom of the reservoir, we can say that that one has a height of 0. So the H1 we can get rid of, because we can just say that H1 is equal to 0. And the other term we can get rid of is the speed of the water at the top of the tank. If you compare the speed of the water coming out of the reservoir hole versus the speed of the water as it's going down, this is such a large area that if you think about it in terms of the equation of continuity, the area is so large that the speed is going to be extremely low to match the volume flow rate coming out of here. This has a really small area, so it has a much higher speed. So we have a really small speed in region 2, and when you take a really, really small number and square it, it becomes even smaller. So much so that we can just say this term is approximately equal to 0. So just to clarify that, I'll write down H1 is equal to 0 and V2 is approximately equal to 0, especially when you have the V2 squared. So now the equation is just simply 1/2 V1 squared. In place of the V1, I'm just going to put down this V, so 1/2 V squared. V squared is equal to, and in place of the H2, I'm just going to put down this H. So we're just going to have GH, and now just solve the equation for the V. So multiply both sides by 2, and then square rootify it, and you have V is equal to the square root of 2GH, Torricelli's equation.